Hi guys, in this video I'll talk about Newton's second and third law and how they can be applied. Okay, so let's start with the second law. Second law says that net external force on the system is rate of change of its linear momentum. Okay, simply rate of change of linear momentum is the external force on the system. Momentum is mv and we can differentiate by the product rule. First differentiate m, then v. In most of the cases you will find that m is constant, so we have f as m into dv by dt, which is a. So f external is equal to ma whenever mass of the system remains constant. Okay, otherwise in rocket cases or any system in which mass is changing with time, we can apply the whole equation to get the net external force. Okay. And the third law is this F on A by B, force on object A by object B, will be equal and opposite to force on B by A. Okay, so this law must be followed, and this pair on A by B, on B by A is called action-reaction pair. They need not to cancel each other because they act on different objects. Okay, we can say that forces occurs in pairs only. Okay, so let's start it with the first example, the most basic one, and we'll see how we can apply Newton's laws, how this F external is equal to ma is applied. Basically this is the cause and acceleration is the effect. You apply forces, you produce acceleration. Okay, the resultant of all the forces will give you mass into acceleration of the object. Acceleration is basically the outcome of the forces. So in case 1, let's draw the FBD first of all. The FBD is like this. The person is experiencing forces from the plank, or this is the weighing machine, normal from the machine, and its weight mg, and these two forces provides it an acceleration in case 1 in upward direction. This is case 1. So we can say as upward acceleration is there, we can say upward forces will be greater, so n minus mg is equal to ma in case 1, and n is equal to m of g plus a. Okay, whenever lift is accelerating upward, normal reaction, which is also called as apparent weight or the reading of weighing machine, will be greater than mg. It will be m bracket g plus a. In the next case, again, it is interesting to note that the FBD will be same. There is no change in FBD. Normal from the plank or weighing machine, mg from earth on the object or on the man, and it is having an acceleration a in downward direction. As downward forces are stronger, only then acceleration will be downward, so we can say mg is greater than this, so downward minus upward force will give you ma. Okay, so how I am writing this equation, acceleration is downward, so downward force minus upward force will give you a net downward force, which is this, equal to the outcome, and n is nothing but in this case m of g minus a. Similarly, when there is no acceleration, we can say n and mg balances each other, so n is equal to mg. When acceleration is not there, object may be moving up or down, it doesn't matter, or sideways, but if it is not accelerating, the normal reaction from the machine will be equal to the weight. Reading of machine will be greater than its weight, less than its weight, equal to its weight. Okay. In the next example, there are two blocks which are placed on a smooth wedge having this angle of inclines. M1 is 100 kg, M2 is 80 kg. We have to find the acceleration of the system. Okay. So let's draw FBD in this. Draw the main forces. The force, this will be mg, m2g, but the component of m2 that will come here is m2g sine 53. Okay, just by equating the values, m2g is 80g into sine 53 is how much? That will be 4 by 5, so we get 64g. Okay, and similarly this m1g will be here, and the component of m1g that will act in this direction is m1g sine 37, so that will come out to be 100 into 3 by 4, 3 by 5 is nothing but 60g. Okay, 64g in this direction, 60g in this direction. We can say the net force F net that will act effectively is 4g, and m net of the system that will accelerate is nothing but m1 plus m2, 180 plus 100 plus this, so 180 kg. So a net can simply be calculated is nothing but 180 by 4g by 180, 40 by 180 will be the acceleration of the system. Okay, this is a different way in which I have solved. You can also solve like this by forming two equations, T, and as this force is greater, the system will move in this direction. If you are not able to find out in which direction system will move, assume any direction. Okay, if the answer comes out to be negative, your assumed direction is wrong. And write down the equation. In this, I will write down downward force when, because the acceleration is downward, 64g minus t is equal to m2a, which is 80a. And the next equation for this will be, as upward acceleration is there, so t is greater than 60g, t minus 60g is equal to 100a. And by adding these two equations, I can easily eliminate t, left with 4g is equal to 180a, and that will give me same a as 4g by 180. Okay, so they are two quite similar method, but in this we need less calculations. In the next example, two blocks 1 and 2 masses are given, and we have to find the acceleration of the system. Okay, similarly I can do like this. Now m1 is 10g and this force will be 30g. So overall the force acting, F effective or F net for the system is 20g downward, and mass that is accelerating, m total, is nothing but m1 plus m2, 40 kg. So acceleration should be how much? 20g and by 40 will give you 200 by 40, 5 meter per second square. Otherwise I can also solve by forming the equations. Let for one, the acceleration, if I assume in upward direction, and 30 kg will move in downward direction, so t is greater than this for this FBD, as it is accelerating upward, so upward forces will win. T minus 10g is equal to 10a, and similarly 30g is winning because it is moving downward. 30g minus t is equal to 30a. By adding these two equations, this and this, I can eliminate t and will left with 20g is equal to 40a. So again a is 20g by 40, which is 5 meter per second square. In the third example, a force F of 500 Newton is applied on block 1, where m1 and m2 are two masses, each of 25 kg. Acceleration of block 2 is given as 4. We have to find the acceleration of block 1. As from FBD of 2, we can say this is accelerating because of spring force, which is kx, and the acceleration is given. So we can say that is 4. We can say spring force is nothing but m2 into a. m2 is 25 into 4. So spring force is 100 Newton, which is acting in this direction on 2. and drawing the FBD of 1, we can say there is a force of F which is 500 Newton, and there is a spring force. As I already told you that spring apply equal and opposite forces on the objects they are connected at their opposite ends. So this force I have already calculated as 100, and the mass is nothing but 25 kg. The net force is 400. So acceleration A1, I will write 500 minus 100 will give you 25 A1. So A1 is nothing but 400 by 25, which is how much? 16 meter per second square. Okay, enjoy.